Aha, this meeting is being recorded. So I think I know everybody online. I'm Mary Bennett, and I'm here because I have an interest in compost in particular and permaculture in general. And in particular, I compost at my co-op with red wriggler worms outside, but they survive the winter. And I try to compost at the Unitarian Church, but that's difficult, especially in COVID times. But I'm hoping we'll learn some more things about that. So I want to acknowledge that I am on the, and Vancouver Unitarians is on the unceded territory of the Tsleil-Waututh, Squamish, and Musqueam peoples. And I'm going to introduce Mike, and he'll talk a bit about his institution. Mike is a member at UCB, possibly most known as being a choir member and the wife of our DRE. And at Kwantlen teaches in the Sustainable Agriculture Department. And so this evening he'll show some slides with an introduction to permaculture and talk about composting in an urban environment and give us all some tips. So he's got a slideshow for about 20 minutes and then do some Q&A. And at 8 o'clock, we'll take a very short break and come back after 2 minutes for anybody that wants to hang around and ask more questions or brainstorm where we might go from here. So over to Mike.
Well, thanks very much, Mary. And I really appreciate the introduction and the invitation to come and talk about composting, because it's always a fascinating topic for me. So I work at Kwantlen Polytechnic University, and of course, Kwantlen takes its name from the Kwantlen First Nation. We have campuses in Richmond, where I work. Also, we have a couple of campuses in Surrey. We have one in Cloverdale. We have one in Langley. So really, we're working on the in that region of the South Fraser that overlaps the unceded traditional and ancestral lands of the Kwantlen, Musqueam, Katsi, Semiahmoo, Tsawwassen, Kaikait, and Coquitlam peoples. And we share this name with the Kwantlen First Nation, Kwantlen meaning tireless runner. And we have our elder in residence, Lakaitan, who is of the Kwantlen First Nation and is a wonderful, wonderful addition to our campus and cultural life there. I'm afraid my camera is trying to show my chest instead of my face here. I'm going to share my slides so we can start talking about composts. So Mary asked me to talk about permaculture and about composts, and I'm not a permaculture expert. I'm certainly interested in permaculture, but I want to, so I'll give a brief introduction to permaculture and try to address permaculture principles as they relate to composting in particular. I'll also say that at the Department of Sustainable Agriculture and Food Systems, where I work, we've really tried to think about our particular values. And I feel like when I'm talking to a Unitarian group, it's probably worth sharing the values, just as Unitarians might share their principles. So our kind of core values program, first of all, sustainability is imperative. Second, good, wholesome, nutritious food, we think, is a basic human right. Co-creation of knowledge fosters citizen engagement and positive change. So I really value opportunities like this to come and share what I've learned, but also learn from you. The pursuit of accuracy and truthfulness are critical for constructive discourse, and science is enriched by honoring diverse perspectives and ways of knowing. And I'll really delve into the current science surrounding composting right now and hope to kind of bring you up to speed with the hot topics surrounding this area. Perhaps you can see the image on the right-hand side. This is our farm at the Garden City lands in Richmond, and you see our solely heated greenhouse in the background, that dome structure, and some of our students planting potatoes in the foreground. Now, permaculture, as our program is based on certain values and Unitarian Universalism is based on a set of principles, permaculture is also based on 3 core ethics and then principles that surround those ethics. So the ethics very simply can be stated as earth care, people care, and fair share, as in not taking more than your fair share. The 12 principles that are surround those core ethics include, and I'm not going to go through all of them, but I think some of the ones that are really important when we start to talk about composting: observing nature and interacting both with nature and with each other. So the permaculture certainly relates to agriculture, but it's also a broader social movement. It has to do with the way people live generally and interact with one another and with their environment. This notion of catching and storing energy is really crucial when we talk about composting, because of course what we're doing is trying to hold on to carbon that's been captured through this process of photosynthesis and keep it in a form that is beneficial to plants growing in that soil. This notion of obtaining a yield is very important when we're dealing with agricultural systems. We want to have some sort of human benefit from the systems that we undertake. Apply self-regulation and accept feedback. The notion here being that we need to recognize there are limits to resources and that we can too easily extend beyond those limits. Use renewable resources and services. So composting is certainly related to this, to renewables and to trying to recycle nutrients in an environment. Produce no waste. Of course, that ties into composting too. We're trying to minimize or reduce the waste coming off of our farms and homes and any land that we manage. I think rather than run through 12, I'll stop there at the first 6, but just survey the remaining 6. They're an interesting and thought-provoking, hopefully stimulating set of ideas. Now, here we are in fall, heading into winter. I hope you see the leaves falling, the brilliant colors, and recognize that that as those leaves are falling off the trees and we head into this season of bare trees, what we're seeing is this massive transfer of carbon from the foliage in the treetops to the soil down below. And of course, come next spring, all those trees are going to put on blossoms and flowers and then leaves, and that process of photosynthesis will begin again. So we can look at this, at the 4 seasons that we go through each year as the earth breathing, because when leaves are on trees and on plants, those leaves are sucking up carbon dioxide from the atmosphere. They're converting it into these complex carbon chains that are the basis of all life. And then come fall, of course, that carbon that's been fixed, that's been stored, is released. And some of it goes into the soil. Much of it will end up back in the atmosphere. We can see this annual cycle. We can think of it as a process of photosynthesis and respiration, and recognize too that as much as this is happening every year, it's also happening every day. So in the morning, as the sun comes up, photosynthesis begins, and carbon dioxide is being sucked out of the atmosphere and into the plants. The plants are forming these complex chains of carbon called organic carbon, and then respiration, which happens inside plant cells and also happens inside my cells and your cells. This is really the opposite of photosynthesis, right? It's taking those complex organic carbon chains and breaking them apart to produce energy and water, and then of course carbon dioxide, which goes back into the atmosphere. The whole process, photosynthesis, of course, is fueled by sunlight. That's the energy source for this endothermic reaction. And then the respiration is an exothermic reaction that gives me the energy I need to sit and talk to you and wave my hands around. And it's really a process in which sunlight, solar energy is being stored and then released when we need it. So I talk about the earth breathing, and this is not just a bit of symbolism. This is something that, with the right analytical equipment, we can track these patterns, these changes in atmospheric carbon dioxide concentration. So that's what I'm showing on the graph here. This is a graph from NOAA in the US, the National Oceanic and Atmospheric Administration. And it's a fairly maybe complicated figure, but a fascinating figure. Look at the x-axis where it says year down at the bottom, and you can see that this particular data set runs from 2005 through to 2014. You can look at the y-axis, the one that runs up and down, and you see that this is the carbon dioxide concentration in the atmosphere, and it's measured in micromoles per mole. So that micromoles per mole are the same as parts per million. You can see this axis is running from 365 to 410. And then the third axis on this three-dimensional figure is latitude. So of course, 0 is the equator, and 60 degrees north would be a fairly far north, and 90 degrees south is quite far south. So we're looking at the atmospheric carbon dioxide concentrations at different points on the planet. What I hope you see is that there are these big waves in the northern hemisphere. And what you're seeing there is every spring, as the leaves come onto the trees, those trees are pulling the carbon dioxide out of the atmosphere, and the carbon dioxide concentration falls. Every fall, as the leaves fall from the trees and plants stop photosynthesizing for the winter, carbon dioxide concentration actually increases in the atmosphere. And you can watch this wave go up and down in the northern hemisphere. Now you'll notice, of course, that the wave in the southern hemisphere is the inverse, and that's because when it's summer in the north, it's winter in the fall, right? And the waves in the southern hemisphere are smaller simply because there's less land mass and therefore less plant matter that's altering that carbon dioxide concentration in the atmosphere. So this cycle has been going on for hundreds of thousands of years, for millions of years, with every summer, the atmospheric carbon dioxide concentration falling. Every winter, it rises again. And of course, for a long time, it was in balance. Now, what you notice in this particular image is that every year, the peak is a little higher than the peak the year before. And that's just the extra carbon dioxide that's been added to the atmosphere, largely because of burning fossil fuels, of this ancient stored carbon that's now being released into the atmosphere all at once. So the huge valleys and troughs are the result of photosynthesis and respiration. But the little extra bit every year is largely the result of burning fossil fuels. And we're all aware that, that the overall effect is a fairly rapid increase in carbon dioxide concentration in the atmosphere. So that's the image over on the right-hand side of this figure, running from 1960 to maybe 2012 or 2013. You can see the atmospheric concentration, carbon dioxide concentration, on average running from about around 300 to over 400 parts per million. But you also see those annual fluxes, don't you? You see that every summer it's lower and every winter it's higher, and that's because of photosynthesis and respiration. Now, that's the image on the right-hand side, one I'm sure that you're familiar with. Now, the image on the left-hand side of this slide here shows other heat-trapping gases, other greenhouse gases, and particularly methane and nitrous oxide, which are very potent greenhouse gases. So I noticed carbon dioxide is in red on that image, methane is in blue, and nitrous oxide is in black. And unfortunately, we see them all increasing since the Industrial Revolution, right? We see this, this hockey stick shaped image where all of these heat-trapping gases are going up. In the world of agriculture, we need to be particularly concerned about the methane and the nitrous oxide, because these are largely effects of agriculture. In fact, in agriculture, we produce a lot more greenhouse gas in the form of methane and nitrous oxide than in the form of carbon dioxide. And these are potent greenhouse gases. So usually when we talk about carbon dioxide equivalents, we compare methane and nitrous oxide to carbon dioxide in its capacity to trap heat in the atmosphere and around our planet. The equivalency is a matter of some debate, and it changes with each update of the IPCC reports. This was from IPCC AR5, so it's not the most up-to-date, but they were saying at the time that a molecule of methane traps about 28 times as much heat energy as a molecule of carbon dioxide over a 100-year time span. And for nitrous oxide, one molecule traps as much as 265 molecules of carbon dioxide over a 100-year time span. So these are potent greenhouse gases. I should say with methane in particular, it only sits around in the atmosphere for about 12 years. It's not a very long-lived greenhouse gas. So the fact that they're judging this over a 100-year time frame really underestimates the actual potency of the greenhouse gas. If you were to look at it on, say, a 20-year time frame, we'd be looking closer to a 90 times the heat trapping capacity. Potent materials. Now, with carbon dioxide, this is largely the result of aerobic respiration, also of burning. So when we're burning fossil fuels or wood or this sort of thing, that's releasing carbon dioxide. The aerobic respiration component there, those are largely natural processes. With methane, methane is produced through anaerobic respiration. So respiration in the absence of oxygen, and also through natural gas leaks. And then nitrous oxide largely comes from high nitrogen soils. So if we're over fertilizing with nitrogen, we create nice environments for the bacteria that turn that nitrogen into nitrous oxide, a very potent greenhouse gas. So how does this all relate to composts? Well, composts are great for so many reasons, right? They retain essential elements, and those essential elements can be fertilizers. So elements like carbon, nitrogen, phosphorus, and all of the micronutrients that plants need can be held in composts. But beyond just producing or just retaining those elements for plant growth, they also help us condition soil, produce soils that hold onto water, that reduce erosion, that fight soil compaction, that buffer pH so you don't get swings in pH. They provide food for microbes. So there are real benefits to adding compost to soil. And by adding these composts, what we're doing in many cases is sequestering carbon for the long term. So carbon that has been pulled out of the atmosphere by plants is converted into stable forms that can persist in soil for a very long time, and rather than being released back into the atmosphere as carbon dioxide. Of course, another great advantage to composting is that it can keep organic materials out of landfills. And landfills tend to be anaerobic. And you'll remember that when we have anaerobic conditions, that produces the environment for methane emissions. So we can avoid a lot of methane emissions if we can keep materials out of landfills. They convert some of this organic carbon into stable forms, so that represents avoided CO2 emissions. Generally, the more carbon we can conserve, the better. And as a general rule, and I'll talk about this a little more, hot composts work better than cold composts if we want to lock this carbon into stable forms. Composts also avoid methane emissions, not just because of the methane emissions that are not being emitted from landfills, but because of the composting process. As long as it stays aerobic, so rich in oxygen, it's a low methane emitting process. The danger, though, is that if our composts go anaerobic, if we allow an environment to exist in our compost piles where there isn't much oxygen, well, that's really going to favor the bacteria that convert carbon into methane, which, as we saw, is a very, very potent greenhouse gas. And a problem with composts beyond the potential to produce methane is that they can also emit nitrous oxide. Often our composts are high nitrogen environments, and if we're trying to add the oxygen in and we have the nitrogen present, that can be a nice environment for the bacteria that convert nitrogen into nitrous oxide, a very potent greenhouse gas. Even if greenhouse gases are produced by composting, a variety of research shows that there are net benefits to composting from a greenhouse gas emissions perspective. So here's a little table from a paper just published last year looking at net life cycle greenhouse gas emissions from composting green waste and manure. So they're combining the sorts of things that we would produce in our yards and in our kitchens, combining that with manure to make a compost, as opposed to putting the manure in an anaerobic lagoon on a farm, or putting the green waste into a landfill. So what they're seeing there is there are emissions, and that's the 5.6 times 10 value that's right at the top of the table. But those are more than counteracted by the avoided anaerobic emissions, the emissions that would have come from the manure in the lagoon, and by the landfill emissions that would have come from putting green waste into the landfill, and by the carbon that's sequestered when you actually put that compost onto the land. So overall, we've got a pretty substantial net negative emission. In other words, the composting process, instead of emitting greenhouse gases, has counteracted the effect of greenhouse gases in this life cycle analysis. Now, composts can occur at a range of temperatures, but there are real advantages to getting our compost piles hot. And what makes hot compost is either a large aerated pile or an insulated aerated pile. So it's important to have that aeration in order to support the aerobic bacteria that do not produce methane. If we allow a big pile, can easily go anaerobic and can start to be a methane generator if there aren't maybe fans pushing air through it or some way of keeping it aerated. Generally, we'll get hotter composts faster if we can maintain a carbon to nitrogen ratio between about 25:1 and 40:1. If we have too little nitrogen, the pile will be too cool. And if we have too much nitrogen, we start to see a lot of nitrous oxide emissions. Beyond reducing emissions, advantages to hot composts are that they kill weed seeds, plant pathogens, and human pathogens like E. coli and Salmonella that might otherwise be a concern if we put waste material onto land that's growing food. And hot composts have the ability to denature most synthetic pesticides, although there are some persistent herbicides that can survive the composting process and even be concentrated by the composting process. And this has caused problems for municipal composting operations. The little chart over on the right-hand side there shows 3 different lines, and each line is a different carbon to nitrogen ratio. So I hope you can see there that the highest line, it's showing that all of the composts heat up as the composting process starts. Maybe after 15 days of decomposition, they reach their peak temperature. And with that, the carbon to nitrogen ratio of about 30:1 in this case, you get the highest temperatures. This is American data, so they're showing us degrees Fahrenheit and peaking out around 160 degrees Fahrenheit. That's a really hot pile. The next one down is a 40:1 carbon to nitrogen ratio, and the lowest one there is a 60:1 carbon to nitrogen ratio. So that's going to represent a lot of carbon not much nitrogen. If you have something like wood chips or sawdust or straw as a dominant part of that compost pile, those are all high carbon materials, and there's just not enough nitrogen for the bacteria to really get going and heat up that pile there. So this is why it doesn't reach the same kinds of temperatures and probably isn't killing weed seeds and pathogens or denaturing pesticides to the same extent. Now, the moisture balance is also really important when we think about our compost piles. If we have too wet a compost, that tends to produce methane because wet environments tend to be anaerobic. And even if the whole pile isn't anaerobic, you're going to have pockets where oxygen can't get in. And that's going to be a nice place for those bacteria that turn carbon into methane. However, as composts get wetter, they also tend to produce less nitrous oxide. So for a while, there's this trade-off between methane and nitrous oxide. However, when you get really wet, that tends to produce a lot of methane and a lot of nitrous oxide. So that's a bad situation. You don't want to let your compost get to be more than about 55% moisture, or else you really start generating a lot of greenhouse gas. And you can see that in the graph on the right. This is from another paper published last year. They're looking at the top one shows total CH4 emissions. Of course, that's methane emissions. And then the bottom one is total nitrous oxide emissions, N2O emissions. You can see the compost pile moisture content running from about 42% to 66% on the x-axis. And you can see those methane emissions really skyrocket at 66%. And the nitrous oxide emissions coming down as the pile gets wetter until you hit about 60%, and then those skyrocket too. So how can we avoid these emissions? Well, one really cool way, and I know Mary's excited about it, is vermicomposting. So this is composting with worms. An advantage to worms is that they mix the compost, they aerate the compost. So you don't need to have expensive fans or blowers to keep oxygen in that pile. The worms are constantly moving through the pile, and they are filling the pile with air spaces. They're making sure that oxygen can get to all parts of the pile to try to reduce those opportunities for methanogens, the bacteria that produce methane. So they also reduce nitrous oxide emissions, and they can do this under a wide range of conditions. So they can function well in wet conditions and in dry conditions. They can work well with high or low carbon to nitrogen ratios. So the worms really help balance things out. Maybe you don't have to be quite so perfect or aware of what's going on in your compost pile. You can kind of let the worms take care of it for you. So this tends to be simpler and cheaper than forced aeration. And the worms are even able to destroy some pathogens despite the fact that temperatures remain low in a vermicomposter. So you're going to have temperatures remaining below 30 degrees Celsius, which is much, much cooler than a hot compost pile. Now, when I talk about the worms in vermicompost, I'm talking about very often this one on the left, Escherichia fetida. This goes by a lot of common names. So red worms, trout worms, tiger worms, red wigglers, they're all names for the same thing. And this is a particular worm that thrives in rotting vegetation, like compost, or also in manure piles. This is a worm that you rarely find in the soil. And this worm just doesn't produce much in the way of nitrous oxide emissions. The conditions in its gut are not suitable for nitrous oxide production. On the other hand, Lumbricus terrestris is the common earthworm, also goes by lots of common names, night crawlers, dew worms. They're common in farm and garden soils, not in compost piles. They form these temporary deep burrows, but they actually feed at the surface, and they have this tendency to actually pull like leaf litter right down into the top of their burrow. And they actually generate high nitrous oxide emissions in their gut. So this is from a greenhouse gas perspective, maybe a more problematic organism. It's an interesting creature too. Both of these worms are native to Europe. They're not native to North America. The earthworm, Lumbricus terrestris, is going extinct in some of its native habitats in Europe and considered an invasive species in some habitats, particularly in the northwest of the United States. So, you know, I guess there's too much of it in some places and not enough of it in others. A point here, of course, is that we need the right worms for the right job, right? And worms that are well adapted to compost piles are not going to be well adapted to our soil environments. Another way we can reduce emissions from compost piles is by adding additives. And there are lots of additives that people have tried with some success in terms of reducing methane and nitrous oxide emissions. One of these is biochar, which is the product of incomplete combustion in a low oxygen environment. So there's an ancient history of biochar use in the Amazon. People would essentially dig pits, put wood into the pits, and then cover the pits, and light the wood on fire underneath the cover, so that you have that low oxygen environment. And what happens is that the wood doesn't burn completely. You're left with charcoal. And if you look at that charcoal under a microscope, it's just full of tiny holes. And you can see that in the biochar image I have on this slide. Another material that's kind of interesting is zeolite, which is microporous aluminosilicate. The product can be mined, so it occurs naturally. It can also be manufactured. In terms of the mined materials, there are large natural deposits of zeolite near Princeton, British Columbia. So we're not far from a source of zeolite. And if we look at that under the microscope, we see that it also has this very high surface to volume ratio, lots of little pores and lots of spaces for things to attach and to kind of capture things. It acts like a bit of a filter. And then another useful additive is actually finished compost. And so this is compost that's already gone through the composting process. It's not going to get hot. And it tends to be full of lots of little pore spaces. You can see the image of vermicompost over at the bottom of this slide, and how much surface to volume ratio there is here. All of these are able to reduce nitrous oxide and methane emissions fairly substantially. So I'll invite you to look at the charts on the right. This is another paper published last year by Cow et al. Now, if we look at the very bottom chart, the green ones, where it says GWP, that stands for global warming potential. And this is a combination of all of the heat trapping emissions from this compost. And anything, you see there's a vertical line right at the 0, right? Anything to the right of the vertical line is actually producing more greenhouse gas, and anything to the left of the vertical line is producing less greenhouse gas. So if you look at the two dots at the bottom, the biochar and the zeolite, you'll see that with a range of studies, this is a meta-analysis, so we're looking at a lot of different research here. Generally, we're seeing a range of between a 50 to 75% reduction in global warming potential when we add biochar or zeolite to composts. That's a pretty substantial decrease. That's kind of exciting. And then if you look at the black dots above it, those show methane reductions. So you can see that a lot of these materials reduce methane. And the orange dots above that show the nitrous oxide reductions or increases. And there we see that it's a more select group of materials that reduce nitrous oxide, and some, like gypsum, actually increase nitrous oxide emissions. So I guess the point here is that we do have capacity to modify our compost to reduce greenhouse gas emissions. Another useful point is right at the top, where it says TN, and there's all of these red dots. So this shows the changes in total nitrogen that retained by the compost. And generally, we don't want to see nitrogen escaping from the system. When we lose nitrogen, we're often losing it in the form of nitrous oxide or in the form of ammonia, which can be smelly and causes an environmental pollutant. We want to keep the nitrogen there in the compost because it's a very valuable fertilizer if we can hold on to it. And you notice that across the board, all of these amendments are actually able to reduce total nitrogen emissions. In other words, hold on to more nitrogen in the compost, and that's valuable. Now, one of the concerns when we start looking at small-scale composting in homes, gardens, churches, is this proliferation of plastic composters. And so a life cycle analysis published in 2016 looked at the entire environmental impacts of small-scale composting and concluded that there were really two main things that were having negative environmental impacts. The first, of course, is these greenhouse gas emissions. And if you look at the sections of the bars that have the diagonal cross-hatching, those are the gaseous emissions associated with various components of the composting life cycle. The other piece that has negative effects on our environment is the composter itself, and that's the section of the bars that that's covered in all the little dots, the kind of gray dots there. Now, this life cycle analysis considered lots of impacts of composting, and I'll just quote from their abstract here. They're saying the composter, so they're talking about the plastic container. The composter was the major contributor to the total home composting process impact categories of abiotic depletion. So that's ADP, and it's the first bar on that chart. Ozone layer depletion, that's ODP, and it's the third from the last bar. And cumulative energy demand, CED, which is the final bar on that chart. You notice that with all of those bars, the impact is dominated by production of the composter, that kind of gray dotted section of the bar. Gaseous emissions, so here we're talking about nitrous oxide and methane for the most part. Gaseous emissions cause the greatest contribution to acidification, so that's AP, eutrophication, that's EP, global warming, which is global warming potential, which is GWP, and photochemical oxidation potential, so that's POP. You notice how those other bars are dominated by the section with the cross-hatching, that diagonal cross-hatching. One more thing I'll mention, when we look at the net greenhouse gas emissions associated with composting, a lot of the benefit associated with home composting is the fact that our home composters keep organic matter out of landfills. The reality, though, is that Greater Vancouver is not putting very much organic matter into landfills anymore. We have our green bins, and we've been diverting most of this waste into commercial composting operations, where our yard scraps and our kitchen scraps are being combined, in some cases with manures or other sources of nitrogen, blended to create, I suppose, a better carbon to nitrogen ratio, and then composted on a fairly large scale. We have a number of these operations around Metro Vancouver. One of them used to be in Richmond. It was an operation called Harvest Power, and it was the biggest one in Metro Vancouver. And it was notorious in this area because of its stink. And so it is about 8 kilometers from where I live. I live in West Richmond. And you could frequently smell this, this composter many kilometers away. It dominated our local media for several years. There was a very active citizen coalition dedicated to fighting Harvest Power and getting rid of Harvest Power, and they were eventually successful. Now, I want to say I think the fact that we were seeing such such smelliness, such stinkiness, is evidence that those piles were going anaerobic, and very likely there were greenhouse gas emissions associated with the composting process, in addition to the volatiles, the organic volatiles that were causing the odor problem. The operation was not being well managed, and it wasn't actually producing terrific compost either. But it was, and I think that unfortunately, it's going to be a long time until Richmond is willing to have a composting operation again. Fortunately, there are other operations that are doing a much better job of taking the municipality's waste and converting it into a higher value compost product. But there's one near Ladner, which is also in the local news because of its stinkiness, and it has been threatened by the government, who is trying to make sure that they take care of the odor problems. One of the ways that they can deal with odors is to actually have the intake facility enclosed, and where I've seen successful low odor composting operations, they tend to dump the raw material into an enclosed area rather than, as this slide from Harvest Power shows, just putting it out in the open. And that's the phase at which there's greatest potential for odor problems, because there's lots of potential for anaerobic conditions before you get that compost into properly constructed windrows with aeration. I guess what I'm trying to say here is that it's important that we have educated citizens who are aware of the value of compost, who aren't afraid to criticize poorly done composting, but also recognize that not all compost is badly done, and that by feeding into this process, by being a part of this process, we probably have a much greater opportunity to reduce organic additions to our landfills and reduce greenhouse gas emissions than by trying, to ensure that every homeowner has their own composting operation. And perhaps there's the opportunity too to avoid some of these plastic bins that may proliferate. So I will just leave you with those thoughts and let you jump in and ask questions or talk. Thank you.
So if people want to ask questions, there's two ways they could do it. You can do it. You can either put your hand up, and I'll try to keep track of everybody, or you can go into the chat, which should be on the side, and you can write a comment there. Okay, so that's what we can do next.
So I see a comment. I see a couple of questions, one from Keith and one from David. And so Keith is asking, where can we get red worms and zeolite? And if not using plastic composters, what is the best use? So in terms of red worms, I'll tell you, I'll hand them out. If you want to talk to me, I can give you worms. And it is, it's almost SCOBY or sourdough starter. You just have to find the right friends, and they proliferate rapidly. So then you can share them yourself, right? In terms of zeolite, that's I'm not aware of a garden center selling zeolite. I know some folks who would love to see people using it locally, and I've been trying to educate about the potential for this product. Honestly, the product is not expensive because it's locally available. So we can probably figure something out, but I can't just send you to a garden center. In terms of getting away from plastic compost containers or plastic composters, so this is a really good question, because we can make composters out of boards and chicken wire. We can dig holes and put compost in the holes. There are a variety of options, but one of the advantages to the plastic composters is they do deter rodents. Now, they're not rodent proof. And this is but I think that this is part of the reason that municipalities often offer the plastic composters at a discount. There is a genuine concern about rodents in our compost.
Yeah, that's what Catherine was asking about. And then David had asked about, well, just make a comment about how many plastic composters that he's gone through. I don't know if that's because it was just too smelly and slimy and all that sort of thing. David, did you have anything to say? You have to unmute. No? Okay, and Lynn has put up her hand.
Yeah, thank you. I have found this incredible. And it's because I've been trying to follow composting for quite a few years now. And this is way more detailed scientific information than I've had before. And I really appreciate it. And there's a couple of things, I am wondering if we can have some kind of instructions that translate all of this into simple, step A, step B, step C, because that's what I need to do this, right? My daughter lives in a rural area with 10 acres and has this sort of open compost. And I'm thinking that it should be covered. I want to give her some, sort of information and advice based on everything we've learned here. And I would appreciate what the condensed version along with, and I'm hoping you can also share these slides so that we can look back and absorb them a little more. So thank you so much.
Yeah, well, I'm so glad you found it useful, Lynn. And I'm happy to share the slides. In fact, I would like to share the slides. I'm not sure what the best way to do that might be. I can email them to folks, or if there's a place where we can archive them. The advantage to sharing the slides is that they all have clickable links, so you can follow the source material. And so, yeah, I'm happy to do that. Now, in terms of your daughter's property, if she's working on 10 acres, she's probably able to generate quite a bit of organic waste or compostables. And yes, I think she ought to be covering that pile. In fact, provincial regulations require that she covers the pile unless she has a proper pad with a roof, right? Otherwise, it's a matter probably of putting plastic over the pile. And that's going to do a couple of things. One is going to keep the moisture content down. And you saw how when things get wet, as they will in the winter in this part of the world, our nitrous oxide and methane emissions just skyrocket, right? And so, we're able to control the moisture content if we can cover the piles. And then the other is that it does, to a certain extent, reduce the organic tile emissions, so the stinkiness of the pile. And so this is why the provincial government, I think, just issued a new set of regulations in 2018 for on-farm composting operations, and it requires covering. It also requires that the compost, well, it requires that the pile not be close to a riparian zone, so a waterway, and I don't remember the distance. And that it be moved. I think you're only supposed to keep it in the same location for a year and a half or something like that, unless you have a permanent pad. So if you have concrete or gravel or limestone pad underneath, then you can have it permanently in one location. I think the concern is that they're trying to limit runoff from the large compost piles. I will say that with a large compost pile like your daughter may have the opportunity to create, there is that potential to to really heat things up, which offers lots of benefits. But it's also necessary to churn it or to have some method of aerating it if we're going to avoid emissions and if we want to maintain that high temperature, which offers many benefits.
I think Nancy has a similar question.
Oh, good. Okay.
Nancy?
Yeah.
You have to unmute.
Yeah.
Nancy?
Yes, we have property in the Gulf Islands, and we do use the plastic composters there because it helps protect it from rain and keeps it enclosed. We're fortunate that there are no rodents on the particular island that we are involved with. But and what I typically do is I transfer it from one bin to another bin on a yearly basis so that it rotates it. So if you want to get rid of the plastic containers, which I understand, you know, the method behind that, but so what do you go to? You go to an enclosed fencing arrangement with a tarp over it. What is the best method? And do the red worms do well in that type of a compost, or is it too hot for them?
You know, honestly, things never get very hot in a small home composter. Like the size of the bins that we use for the plastic bins we use for composting, it's just not big enough to really get any heat. Unless it were, you know, if you used an insulated container, you might get some heat in there, but generally we don't.
Okay.
So I'm trying to imagine kind of the scale of your production system on the Gulf Islands. I really like the idea of transferring material from one area to another. That aerates it, and it also allows you to have kind of a production line, right? So where you've got the more finished compost over on one side, and that's what goes onto the garden, and the fresher material is over here. We do something very similar to that at the farm. In terms of getting away from plastics, I'm not sure if you have access to. Sometimes you can find old pallets and sort of lash together pallets, and you can use chicken wire as a way of reducing rodent invasion. You're very fortunate you don't have rodents on your particular island. We use hay bales and create structures out of hay bales. And the hay bale itself eventually becomes compost. It rots and becomes a part of the pile down the line, but it provides a bit of a structure for a relatively large pile, and also a lot of insulation, so we can try to get some heat. Generally, if we're wanting to aim for a hot pile, you know, that 150 degree Fahrenheit kind of pile, I want to have a pile that's at least 2 meters in all directions. So it's a big in order to get that much heat.
Wow. Okay, thanks, Nancy. Marie, you had a comment?
Yeah, so I'm a city composter, no land, just using the green bins. I was wondering, most of my friends are also just apartment dwellers, and I was wondering what you think is, if I'm chatting with them in casual conversation, you know, hoping to educate people on this process, because to be honest, I don't really even know where my waste goes when I send it in the green bin, which thank you for telling us a bit about that. But when I'm chatting with my friends who are in the same position, what would be a good shareable tidbit? What do you think is the most important thing that I could say to people in casual conversation that would help educate about this process that we're a part of?
You know, I think a lot of people are in your position and my position, not having land. You know, this is the reality of being in a city, and it's you know, there's a tendency perhaps to think that we have to go back to the land to live a sustainable lifestyle. And of course, the reality is that urban dwellers tend to have a lower footprint in many situations, simply because we're kind of all working together, and our composting operations, our municipal composting is an example of that. I think that the shared composting, the fact that we have a green bin is a real, it ought to be a point of pride. This is not something that every municipality has, and the fact that we can participate in this is really, really valuable. So I think if you're sharing something with your friends, it's more just using the facility, using the green bins is really important. Not putting the darn bits of plastic into the green bins because when I'm on the farm, I get little fruit labels and all of that stuff. It doesn't disappear. It comes through, and the composting operations have to they put everything through sieves. They invest a tremendous amount of effort in getting the plastic out of those of the compost, the finished compost. But for things like fruit labels, it's impossible. It's going to end up back in the soil on the farm because we're recycling those nutrients, but we're also recycling the waste. So we do need to be careful about what we're putting into the green bins. If UCB, for example, decided that we need compost for our gardens, which I think would be a tremendous thing, we can get a pickup truck load full for about $8. And when we compare that to the cost of getting another plastic container, it maybe makes more sense just to take advantage of the municipal composting system. And that actually reduces a lot of plastic use by using the community operation as opposed to to trying to do it all on our own, everybody. And so maybe that's something that apartment dwellers can take pride in, the fact that they're part of the beehive, right? Rather than trying to operate as solitary creatures.
Wow. Oh, Sandy had the same question I had, is that there's these things called compostable bags for your produce that you can put on the green bin. Are they?
So there are compostable plastics, and these are plastics that break down under very high temperature conditions. In a well-run municipal composting operation, they should reach a high enough temperature that they can destroy those plastics. Unfortunately, it's very difficult for the composters to tell whether a plastic truly is a compostable plastic or not. So at this point, when there's so much other plastic waste going into our composts, most of those compostable bags get treated as if they're just plastic, because it's just too much trouble when you're on the other end to figure out what's compostable and what isn't. And the compostable bags certainly won't be compostable in a home composting bin. We're just not going to get the heat to break that down. And another concern about the compostable bags is that they, they're usually based on soy or corn products, which is fine. But there are often, there's often a petroleum component to those compostable plastics. And what's happening during composting is more that it's breaking apart into little bits rather than actually being destroyed or entirely being destroyed by the composting process. So, this has been a really hot topic in the whole organic agriculture sector, because when the compostable plastics first came out, people were really excited about them and used them all over the place. And then the organic standards were eventually changed to eliminate the use of the compostable plastics because it was just resulting in so much microplastic waste in the soils.
So I noticed that we're nearly at 8 o'clock. So Mike, I got to say, I love your enthusiasm. And to be perfectly honest, even though I'm a keen composter, I've never thought about the emissions from my compost before. I mean, some of what you've said I follow in terms of keeping it moist, but not really, really wet, because that's what works for making good compost. So I gather now we're going to just have a quick 2-minute break if you have to go to the washroom, check the US election results, get a drink, maybe both of those together, and then we'll resume with some more questions or comments for Mike.
Great.
Thank you so much.
Back. Yeah.
I want to apologize for the phone ringing. It was my friend from California. Need I say more?
Oh, David, you're staying here. Good. Oh, 'cause I'd like to know about your question.
Kind of stay near me. Hmm.
That was the same one that you had put something about. Is it the same kind, the Japanese?
I don't know if it's the same one. That's
Okay.
I'm wondering.
Because I was wondering about that as well, because it sounded like you could keep worms in your house and they weren't stinky. I like that idea.
No, I don't think that there's worms. I think it's just a way to compost indoors.
Oh, okay.
Do a quick Google.
Yeah, that time went by really quickly.
Mm-hmm.
And I see everybody staying on because we're so fascinated and we have so many thoughts to share. That's great.
Huh.
Hi, Jan.
Hi, I'm sorry I couldn't get here earlier, but
All good. You actually just made it just in time we're just about to move into the informal discussion. So we'll still be having a good chat.
great.
Yeah, nice to see you.
Yeah. And also this is going to be taped. So there will be a tape available because he taught us a lot. It was like a, KPU class. I want to go back over the tape and relearn it all. A lot of it went right.
Okay.
So the tape will be out at some point. We'll make it available.
Right. So I just was wondering if we could just have people make comments based on their order in the chat. We've got David, Keith, and then Catherine. Would that be okay?
Yeah.
That sounds good.
David, do you want to go ahead?
Yeah, my question was just about, I remember trying the Bukowska method. I was wondering if Mike had any comments on that.
Yeah, I believe that the bokashi method is it's a fermentation process, and the idea is that it works well in an enclosed environment associated with the fermentation. So I think that's it's a neat idea in terms of emissions. When we're fermenting, we're intentionally creating an anaerobic environment, right? And there's potential for methane emissions from that. Now, of course, there's also opportunity in an enclosed environment to capture that methane, and people at all sorts of scales actually create anaerobic digesters, right? So where they're intentionally capturing the methane and then burning that rather than ensuring that it's released into or ensuring that it's not released into the environment. So that's a kind of another way of producing useful agricultural product from waste materials. I guess that's what I think of when I think of the bokashi method. Does it with your experience?
Yeah, I remember trying it once, but it didn't go so smoothly. So, and then we moved, and then I had another plastic bin to use.
I have an uncle who is he's an inventor. He's always coming up with something new, but he has this compost bin under his sink that has a little electric motor, so it's constantly aerating itself, and it's insulated, and he might even have some heating elements in there. So he's creating a very hot environment. He's adding wood pellets as a carbon source, and he's able to go from like kitchen scraps to finished compost in about a week under his sink. It's really, really kind of amazing.
I wonder how much energy he has to put into it, though.
I know, that's
Yeah.
exactly it, right?
I like it, though.
Yeah.
A good effort.
Thanks, David. Keith?
Well, I just had commented that I have these rotating plastic bins that I've had for about 15 years, and they still are working fine. Got them at Lee Valley. I don't intend to replace them, but they provide the benefit of being able to aerate quite easily. And so I've got the worms who migrate out of the bin, and I think it means they're too wet. So I've been putting in dry stuff like brown paper, shredded brown paper. And they're kind of a lot more convenient than the old wooden bins that I used to have to build, and they do rot and so on. So, and then I've always been curious about what happens to junk that gets put in those green bins. I think, well, people put all sorts of stuff in there, and I think, I don't know, are they going to get that out of there, or is this just going to go into landfill? Do you know how that is managed?
So yeah, there's a real effort to get rid of the junk. So first I'll comment on the plastic bins. I think it's wonderful that your bins have lasted 15 or 20 years. And if they've still got life in them, by all means, keep, it would be crazy to stop using them, right? The point is, not to start buying a whole bunch of
new ones. Yeah.
And I think in the life cycle analysis that I shared with you, where we were looking at the various impacts of elements of the composting process, the base assumption was that the bins would last 12 years. So you've already gone beyond their assumed lifespan, and anything else you get out of them is bonus, right?
Okay.
So yeah, if that's working for you, I think that's tremendous. Yeah, getting the plastic out of composting facilities is there's a lot of plastic that goes into composting facilities, and there's a huge effort to remove it just before they're going into windrows. They'll be picking material out. I saw a video of folks in Edmonton where they were dumping all of the compostables into a hockey arena, and these guys were going in with hockey sticks and flipping plastic out of the compost.
Sort of the Edmonton de-oilers.
That's right. It seemed like a particularly Canadian solution, right? But anyway, yeah, getting it out at the beginning, and then at the end, after composting is done, they go through several screening steps, and they're able to get rid of all of the big chunks of plastic. What you'll find in composts is just the little pieces, and those darn fruit labels are the bane of my existence. Those are really difficult to get out. And it's so silly too, because it's easy to make fruit labels out of paper. I don't understand why they need to be made out of plastic.
Okay, thanks, Keith. Catherine, you next.
Well, I was going to comment as well. It's not just the fruit labels, it's those very high-end tea bags that I didn't know until I'd put them through my compost that they were made of plastic. I assumed they were a very fine mesh paper. So now I've got hundreds of those in my garden. I keep fishing them out.
Yeah. The high-end tea bags bother me a lot too. It's cheap tea bags are paper, aren't they? And when you pay more for tea bags, you get
yeah.
It's really frustrating. The other thing I found was I thought that butcher paper was actually paper until I put it in my worm composter and realized it's a laminate with plastic. And the worms did a wonderful job of removing the paper and left me just with this fine film of plastic.
Oh my gosh, is that right?
Yeah.
So all those meat products that we get that are wrapped in paper, that shiny side is not waxed anymore.
Yeah, I thought it was wax, but no, it's a laminate. And the worms educated me.
Yeah. My other question was about like there's a massive amount of horse chestnut leaves that fall on my street. And by and large, the city takes care of them because it would take thousands of bags for me to load them all up. But one year I did spread them on the garden, and it was not a very happy experience. And when I read up on it, there's a mild biotoxin, but I wondered whether composting will eventually get rid of that.
Yeah, I think that composting breaks down a lot of compounds, and certainly some of these toxins produced by plants will be broken down by the composting process. I would have to read up on exactly what is in horse chestnut. but this various forms of allelopathy, where there are toxic chemicals produced by plants, are pretty common, and composting tends to destroy them.
Uh-huh.
Okay. Cindy, you next.
Yeah, I was, I used to have a compost, one of those plastic ones, and then it got rats in it. So I was thinking how to keep the rats out of the plastic compost, or you mentioned chicken wire, but how does one actually do it? But then when you mentioned about the municipal load of compost for $8, that might even be a better, like we just put in some community gardens in my townhouse complex. And so it's not a big thing, but would it be better just to get the municipal? And if so, how does one get that?
Yeah, so now you have municipal, you're part of an allotment garden or a municipally run garden?
No, basically I'm in a private townhouse complex. And so we have, the municipality comes and takes our green bins and our other recycling, but we actually have private garbage that they come in our garbage.
Okay.
So I don't know if they would give us the municipal compost, and if so, how would we get it?
So Metro Vancouver is running a composting facility right at the Vancouver landfill, and so they're composting right there, and you should be able to show up with a pickup truck, and they'll scoop a load in for you.
Okay.
So it's not difficult. Just look them up online, and you'll find how to access that.
Okay.
Yeah.
Sounds good. And that's probably sounds like a better idea than doing the green bins and for.
You know, I think that there's real value in doing that. If your goal is to get a lot of compost that you can use as a fertilizer, purchasing a truckload is going to be far faster and quicker than starting from scratch. You know, it's a long process to go from waste to compost, and I'm sure that all of us who have done this in our backyards recognize that there's really not that much that comes out of it. You know, you can compost all year and you get a little bit, right?
Right. Yeah, okay, sounds good.
So I had wanted to just buy half a dump truck full of compost, and share it among two houses. And the cost of getting a truckload is what was really expensive. The compost, the soil itself is really cheap.
Yeah.
Getting it out into Vancouver, because I guess they all come from Surrey. It's not, it's like over $100.
Yeah. So that's interesting. Who were you getting it from? It was somewhere in Surrey, obviously.
Yeah.
Yeah. It shouldn't have to be. I agree that delivery is expensive, and it's by far the most expensive part of the whole thing. So, there's a bunch of people creating massive amounts of compost for these mushroom operations. They generate all of this spent compost, and they give it away. But to get a lot of it, you've got to pay for a truck, and that's going to be the expensive part. So. Probably, I mean, there is the municipal composter in Ladner that's currently got people up in arms. It's a lot closer than Surrey, and there are operations in Surrey. We don't have one in Richmond anymore, but then there's the one in Delta at the landfill also. So I think you probably have closer options, and if you could find a friend with a pickup truck and go pick it yourself, I think you'd probably be in better shape than pay for somebody to bring a truck into town.
As soon as they found I lived near UBC, I got the full maximum fee for doing it.
Right. Yeah.
Does anyone else have questions? Do you remember I had posted, I think you may have even commented on my Facebook, that there was a New York Times article about a Japanese way of composting inside your apartment. And they said they do not use plastic because that just sort of sweats and keeps everything really wet. And they do it with cardboard boxes, which that really surprised me. And then they also use, I think it was like biochar to speed it up. Okay. I'm just wondering what you thought of that. Is that possible?
Yeah, I don't remember seeing that post. I don't think I commented on your Facebook post.
I think Mary Bennett was saying, what do you think?
Yeah. No, the biochar it is really interesting in its capacity to hold on to nitrogen. And yeah, I think there's real benefits to including that or similar materials in a compost. And that's kind of cool that they're using that in their indoor operations. I think it's also going to really help reduce odors.
I think it was ash because there was a conversation about people getting ash from their fireplaces in that. Yeah.
Okay. Well, biochar is very similar to ash. The difference is just that, you know, a home fireplace is going to be a pretty high oxygen environment, and biochar tends to be produced in a very low oxygen environment. And so it just means that there's more char left over, more charcoal left over, and more of that. What you're really looking for is all of those little holes, all those nooks and crannies that seem to act as a bit of a filter and capture some of these molecules.
Where would one get biochar?
You know, there are a couple of people in this area producing biochar. It's mainly experimental, and at least from an agricultural perspective, it's just too expensive to justify broad scale application. But I think that for a compost, it would be perfect for a kind of compost scale. Let me see if I type in biochar. I've got a browser in front of me. Let's see biochar Vancouver, what shows up here. So Canadian Agrichar, which is nature's wonder product. Yeah, they've got a little trailer that they're using. They can pull around and produce biochar in various locations. But if I remember correctly, I've looked them up before. If I remember correctly, most of the char they're actually made in Washington State. They've got their trailer for demonstration purposes here. Go to canadianagrichar.ca and they've got a big buy now button.
I should say that I have enough here, but I'm on Salt Spring that I could bring like some bags over. I don't know if people could make biochar the way I do here, which is I just dug sort of a V-shaped trench in a field here and get a really hot fire going at the bottom of it with dry wood, and you can put wetter wood on top, but basically you want it all to be pretty dry and just pile it on so that the wood at the bottom eventually runs out of oxygen and then it doesn't turn to ash. So it's pretty low technology way of doing it, but it works.
Yeah. Well, I think, and people have been doing this for thousands of years, and essentially doing what you're describing.
But I know you already covered this, but if you have time, I'm just curious about how you mitigate releasing carbon into the atmosphere from composting.
Yes, I did cover it. In fact, this is kind of the whole talk.
Okay, yeah. So I'll watch it later or check online.
Great.
Yeah.
And Nancy has had her hand up.
Yes, I was noticing that Cindy asked a question about, does parchment paper compost? And I just wondered about the answer to that.
Yeah, you know, I think it does. I'm trying to remember if I've put it into my worm bin. I think I have, and I don't think it's come out the other end the way the butcher paper did.
I tend to put it in my green bin. Hoping
Okay, yeah.
it will be okay in the green bin.
Yeah, I'm pretty sure it's just paper. Yeah.
And I also read that there was two kinds of butcher paper. There was a kind that was compostable. It was just a Google search, and a kind that wasn't. But then when I looked at what I get from Steve's farm, where I get my beef, it's shiny. So I figure it's the other kind that doesn't compost.
Yeah, obviously whatever I had was the other kind.
Yeah.
No other questions? Mary, would you like to say something?
Well, I just think that's been a great discussion. personally, because I love my worms so much and I love to watch the leaves and stuff turn into compost, I'm grossly disappointed to hear the idea of just buying the compost. So I want you all to just adjust your attitude to it's not just about making compost, it's participating in the interdependent web of all existence of which you and your worms are a part.
And I'm definitely cheering Mary on for her composting that she has done at UCV over the last few years since I've been,
Yeah.
gardening there. And this
Naturally improve
summer,
the soil.
the soil that I had this summer that I grew these zucchini on was incredible, thanks to Mary. Like it's full of
Yeah.
worms and composters, and
Yeah.
it was
Haven't been
really
able to get
fun.
up there much during COVID, but
Yeah.
hope to get it going again. Yeah.
Yeah, I didn't actually know that you could put worms into a composter. I thought it was sort of a whole separate kind of composting that was these worm composters that you had to bring in the winter. That was the last time I looked up worm composting. So
Well, they tell you that, but in our climate, if it's in a big black bin instead of a little tiny place, it's warm enough that they just keep going over the winter. They don't multiply as fast, but they survive for sure.
okay, and then the other thing I was a bit confused about in this talk was, is it harmful for those red wiggler worms to go into the soil in the ground? Because it sounded like they weren't compatible. Maybe Michael could clear me up because I'm a little confused.
So no, it's not harmful. I think, like Mary, I enjoy watching the worms and I enjoy participating and kind of watching them, if they're thriving, if they're reproducing rapidly, and if I've got a vigorous population, I feel like I'm doing something right. And if the population crashes, I realize I've done something wrong, that it's too wet or I've added too much nitrogen or something like that. And I know we had a little bit of a Facebook discussion a little while ago where Mary said, well, what's wrong with just letting the worms go into the soil? And of course, nothing's wrong with it, except that they'll die and I feel bad for them. They have their ideal environment, which is rotting vegetable matter, and they're not going to survive in a regular soil environment. But other than that, I mean, I suppose when I add the wrong worms to the soil, I'm just adding organic matter, and I just have to, value it for that. I feel bad sending them to certain death.
So better to pick them up and put them back in your composter then.
Yeah, but this is the real challenge too, in that separating the worms from the compost is not easy. So because I was afraid of having a frozen block of worms, I bury my composter, as in it's just sitting in the soil, so it gets some of the heat from the soil in the middle of winter. And I can certainly, agree with Mary that they survive just fine. Everything slows down in the winter, and I think with both a regular, non-vermicomposter, or just a regular composter, and a vermicomposter, we have to treat the composting as a seasonal operation where, there's not going to move very fast in the winter time. When things warm up in the summer, we get a lot more activity. And this is a difference between our cool backyard composters and the large scale municipal composters, where they've got the scale and the size of those heaps to keep things hot year round, and it's not going to slow down in the winter time, right? So yeah, that's you can buy worm composters that are elevated, and the idea is that the compost is removed from the bottom so that it's kind of a flow through system, and the worms stay up near the top because you're putting the fresh material in at the top, and the worms are attracted to the fresh material. Once the compost is finished, they're not so interested in it because there's nothing for them to eat there anymore. And so that's those kind of elevated systems can be really nice for separating out the compost from the worms. But because I want mine down in the ground to keep them warm, it is more of a challenge. So what I end up doing is I end up, my composter is only like a Rubbermaid bin. It's not very big. And I dump it all out on a tarp. the sunlight causes the worms to head down. You know, they don't want to be out in the sun. And so then I can take the compost off the top and throw that in the garden. And I'm just chasing the worms down. I take off a layer and throw it in the garden, that kind of thing. Another system that some people use is just like having two bins, two worm composters, and they'll put the fresh material on top of one composter, and the worms will be attracted up to the fresh material, and then they'll dump the other bin on top of it, and the worms will go down to the fresh material so they can take the clean material off the top, kind of, and then you kind of move things back and forth that way. So, you know, so there's a few different strategies when you recognize the behavior of the worms, you know, the fact that they don't like light and they want the fresh material to eat. You can kind of deal with them, but yeah, you know, or you can just as Mary kind of isn't as soft-hearted as I am, and she just lets it go into the soil and let them cells for a little while.
Otherwise, unless you've got millions of friends that want your worms, they just eat each other over time. That's what happens. They're cannibals. No, I'm serious. Because the bin can't sustain a 99% worms versus 1% organic material. So.
That's very interesting idea.
But I had a friend that was really into composting, and she didn't like doing vermicomposting because she didn't like having the worms in amongst their garden. But they don't eat the roots of like growing things. They'll only eat dead stuff. So, you know, doesn't bother me.
Yeah, and
They'll
there's not going
eventually
to be enough in the garden for them to eat anyway, really.
No.
Do those rotating composters, are worms in that? Because that's above ground.
I'm not aware of people putting in worms, but the goal of the rotating composters is to make it easy to aerate. So by turning it, you're mixing everything up and introducing oxygen into the pile, so you don't have to like flip over the pile or something like that. So yeah, that's a great advantage to the rotating compost, but the worms are doing much the same thing. You know, we don't have to go in and aerate with a vermicomposter because that's what the worms are doing for us.
Diane Crosby had one of those rolling ones, and she had worms because she was always bringing worm tea to sell it as a fundraiser.
Ah, yes.
That's
well, doubly aerated then. The worms and the turning will all be aerating, but I'm not sure that it's really necessary.
Okay.
Michael, how do you keep the rats out of your Rubbermaid bin that you bury underground?
Knock on wood, it hasn't been a problem yet. It's a lid, you know, but yeah, they haven't. We have raccoons around and rats and mice, and they haven't found it.
Okay, so you actually keep the lid on the Rubbermaid bin?
Yes, it always has a lid on. Yeah, that's right. Yeah.
Okay. Cool. Well, what a great, interesting conversation.
Yeah.
Yeah. Well, thank you all for your interest.
Well, thank you for your
very much.
Yeah, thank you, Michael.
Fascinating.
Thank
Good.
you.
Cool.
Okay. So does somebody want to give a promo for next week's session?
Lynn.
Yeah, well, next week we're not having a Wednesday action evening. We're hosting a really special ceremony with the white poppies. Let Peace Be Their Memorial. And I'm hoping everybody will tune in. And then we're going to resume the following Wednesday, November 18th, I think, with another All Genders Welcome. Yeah, thank you.
Okay. Well, good night, all. Thanks very much, Michael.
Thanks so much. Thanks, Marie, for your work back behind the scenes, too.
Thanks, Mike.
Thanks so much. That was great.
Yeah, that's
great.
Thank you.
Bye.